Good morning. This is lesson one, transversing the plane. So it says, how far is point A from point B? So we want this distance. I don't think we've introduced the distance formula yet. So the way we would find this distance is by seeing what the horizontal distance is and the vertical. Now notice a vertical line and a horizontal line are going to make a right angle. So if I count my units for this distance right here, I get 1, 2, 3. So this distance is 3. The horizontal is 1, 2, 3, 4. And so I have a right triangle. I have two sides of that right triangle. And I want the hypotenuse, which will end up being the distance that I want. So some of you may recognize that this is a Pythagorean triple because my sides are 3 and then 4. Or if you don't recognize that, that's fine. You can use the Pythagorean theorem. AB is the line we're looking for. That's why I put AB squared. All right, so this would be 9 plus 16. 9 plus 16 is 25. And square root of 25 is 5. Or again, if you recognize that's a 3, 4, 5 triangle, then you do not have to do all that work. What transformations will take point A to point B? Okay, so they're saying like, how would I move A to get to where it's on top of point B? So I would say translate. Remember, translate is just another word for move. Point A down 3 units and right 4 units until A, which has the 0.35, coincides with point B, which is the 0.12. Now, normally in class, I would pause and give you some time to write this down. This is a video, so just pause the video if you need more time to write that down. First, predict where each transformation will land and then carry out the transformation. As it says, number one, rotate figure H. So there's figure H. Rotate figure H clockwise. So just kind of remember this is a clock. Clockwise moves this way. Then this way is clockwise. So this way would be counterclockwise. All right, so rotate the figure clockwise using the center 2, 0, which is this right here, which is going to make it easy. By 90 degrees, translate the image by the directed line segment 2, 0 to 3, -4. Label the result R. So basically, we're taking this figure and we're rotating it this way 90 degrees. So it's basically just going to look something like that. And then we're moving it. Let's go ahead and do that. So I'm going to kind of, let's do the rotation first. I'm going to end up erasing some things, but we're rotating at 90 degrees. So basically, I'm just taking this and shifting it sideways. All right, so this point stays. This point will now be underneath. This point will now be straight across. And this point will be here. So there's the 90-degree rotation, and then 2, 0. The point 2, 0 is now at the point 3, -4. So here. So just connect your points. And I'm just kind of using the original image to help me with my points. For example, this distance here to here is 2 units, and then this distance here to here is 2, here to here is 3. Just to help me get my points. Okay, there's R. So I did that one. Reflect H across the y-axis. Okay, so let's do that first. So here's the y-axis right there. It's the vertical one. So reflect H across the y-axis. So if I'm doing this point, it has a distance of 2 to the y-axis. So I'm going to go 2 on the other side. So here. And then straight down will give me the bottom. Straight over will give me that. And then up 1, 2, 3 will give me that one. So doesn't look very good, but all right. And then I'm going to rotate it counterclockwise. So I'm rotating it this way using center 0, 0 by 90 degrees. Okay, so this can potentially get complicated. I'll just kind of show you how I do it. So for example, if I'm doing this point here, that's from 0, 0, that's just straight across. So 90 degrees would be straight down here. So essentially I'm just moving it like that. So now that I have that point, then I can just draw the rest of them. It's not that, I don't have to like perfectly get everything 90 degrees. If I just have one point, I can finish drawing the rest of it. Okay, and that is L. Oh, okay, that's it, just those two. Yeah, so again, with both of the rotations, I just really just rotated one point and then I just drew the rest of the figure because it's a pretty straightforward figure. You know, like if you have one, then that's 2 across, that's 2 across, that's 3 across, and then you can connect that. So, yeah, that's how I did that one. All right. Calculate the length of each side in the triangles. Okay, pretty straightforward. Let's do ABC first, which is the blue one. So AB, I mean, you can just count, it's just 3. And BC, you can count as 2. So AB is 3, BC is 2. So to get AC, I would need to use the Pythagorean theorem. So 2 squared plus 3 squared is going to equal AC squared. That's going to be 4 plus 9 equals AC squared. So that's 13. And take the square root, and you get square root of 13 equals AC. I'm just going to leave it like that because that's the most accurate. So AC is equal to the square root of 13. Okay, green one, DEF. EF is 2. DE is 3. So Pythagorean theorem, which if you notice, it's the exact same numbers that we had. So you should know that you're going to get the same thing. You shouldn't really have to work this out, but I'm going to just in case. So square root of 13 is DF. All right, so I'm going to try to make sure I get the right ones. All right, DE is 3, EF is 2, and DF is square root of 3. Calculate the measure of each angle. Okay, well, Angle B is going to be 90 degrees because it connects a horizontal line and a vertical line. So now let's find A. So we're going to have to use trig. So the opposite side is 2. The adjacent side is 3. And I could have used the square root of 13 if you wanted to. I just always use the easier ones. All right, so opposite and adjacent is tangent. So it's going to be tangent of angle A is equal to opposite over adjacent. So remember, we take the inverse tangent of both sides, which will leave me with A is equal to inverse tangent of 2/3. Use your calculator. So inverse, well, first of all, make sure your mode is in degrees, mine is not. Okay, inverse tangent of 2/3. And I get, let's go ahead and round that to 34. So this is gonna be 34 degrees. And then angle C will just be 90 minus 34 degrees. 90 minus 34. And you get 56. Okay, so angle A is 34 degrees. Angle B is 90 degrees. And angle C is, what did I say, 56 degrees. Okay. That is the first triangle, second triangle. All right, so angle E is going to be your 90. So let's try angle F. So for angle F, 3 is opposite and 2 is adjacent. So that would be tangent of angle F is equal to opposite over adjacent. So F is the inverse tangent of 3 over 2. So inverse tangent of 3 over 2. And you get about 56. So 56 degrees. And then angle D would be 90 minus 56, which is 34. So angle D is 34 degrees. Angle E is 90 degrees. And angle F is 56 degrees. Sorry, that's kind of, what do you call it? Just crammed in there. They didn't give us a lot of space. Okay, so the triangles are congruent. How do you know this is true? Well, we just proved that all the corresponding angles were congruent and all the corresponding sides were congruent. So just D, D corresponds with A, and F corresponds with C, and E corresponds with B. And so then you can actually think about the sides that correspond are the ones that connect the same color angles. Anyway, so how do I know this is true? All corresponding sides and angles are congruent. So for example, angle A is congruent to angle D, angle B is congruent to angle E, angle C is congruent to angle F, and then A, B, and D, E are congruent, B, C, and E, F are congruent, and A, C, and D, F are congruent. Because the triangles are congruent, there must be a sequence of rigid transformations origin motions that takes one to the other. Find the sequence. Okay, that takes A, B, C to D, E, F. Okay, so they're saying, what would we have to do to move this triangle and get it to be on top of that one? Okay, so let me kind of, I feel like I need to erase so we can like see a little bit more. But I don't want to erase too much. Okay, so the first thing I would do is rotate ABC until it is, I don't want to call it upside down, but it looks like that. So if you think about it, I'm just flipping it a fourth of the way, and that's 90 degrees. So first thing I would say is rotate. It's too big. Rotate triangle ABC. What that direction would be clockwise. Clockwise, 90 degrees. And then, so let's say at center A. At center A. So what we've got now is once I do that, it's going to look like this. And so then I'm going to translate it down and over so that it then lines up on the other one. So then translate triangle ABC down 1 and left 1, 2, 3, 4, 5 until triangle ABC coincides with triangle BEF. There you go. And don't worry about that. Okay, that's lesson 1. Pause it, do whatever you need to do to get the notes done.